Hello, and welcome to season one of the Autonomous Health Podcast. We talk to scientists, innovators, entrepreneurs, VCs at the intersection of bringing machine learning and artificial intelligence to healthcare. I'm Anmol. I'm a computer scientist and entrepreneur working at the intersection of healthcare and AI for the last couple of decades. And alongside me today is a really exciting guest, Randall. And Randall will introduce himself in just a minute. But the story of how I got connected to Randall and is part of the reason I'm doing this podcast is I run into all these interesting people. And I had 2 or 3 people who I really respect and value come and say, hey, you should talk to this guy. And he's doing some really interesting things at the intersection of safety and natural language and all sorts of possibilities, given some really compelling experience in autonomous vehicles and safety. So that's how I got connected to Randall. We had a couple of fun chats, and I feel like this is going to be a really interesting discussion. So Randall, welcome to the podcast.
Hey, thanks so much for having me. I'm really glad to have the conversation.
So I know there's a lot for us to cover, but I think let's start by having you just introduce yourself and tell us about yourself and what you've been doing, what brought you to this point, and maybe a little bit of personal history too.
Absolutely. So I come from a background in experimental physics, and in undergrad and graduate school, I was really interested in sort of the fundamental way that the universe works. And so I did a bunch of experimentation around Big Bang cosmology. And in my time there, I spent basically equal parts on hardware and software. And that has been sort of a theme through my career since, is that I really enjoy working on safety critical applications at sort of the intersection of hardware and software. I've also spent time on disaster relief technologies, remote sensing, LiDAR, and then I spent about 8 years working on autonomous vehicles with a lot of focus on safety. And I think that there's a good argument to be made that autonomous vehicles are one of the largest large-scale applied AI deployments that has happened in history. And I think that we've learned a lot of lessons about not just how to make AI safe, but how to develop AI safely. And what we found over time is that making the models themselves better is about half the battle. And then the other half of the battle is proving that they work well and implementing the right guardrails to make sure that they behave and obey a certain set of rules. Now, when you're driving on the road, those rules are really easy to define. They're literally written in books. And I think as we get into this next generation of generative AI deployments, there are going to be similar rules that need to be enforced in a variety of contexts. And I'm pretty convinced that we can't always rely on the models themselves to behave. So I think that my interest here is really about how we deploy AI in the near term. I think that the conversations around existential risk with AI are important, and those are risks to be taken seriously, but that's not really my focus. My focus is how do we keep these things from doing things that they shouldn't, and how do we manage the risk associated with them in the near term?
Yeah, there's a lot of what you said in there that is worth unpacking.
Awesome.
And I think for reference, for everybody who is just listening, when Randall says he does hardware and software, there's literally a mechanical engineering workstation, I think, right behind you in the video frame. He really actually does hardware. And as a person who was trained in electrical engineering but gave up hardware pretty early on, I think hardware is way harder than software. So going back to what you said, I think you said something really interesting before we even get to safety. You said that autonomous vehicles are the largest real-world AI deployment in sort of our society. And can you elaborate on that, Randall? Because I don't think that's obvious to a lot of people. And just to kind of give you a counterpoint, a lot of people believe that autonomous vehicles are still early, they're still, sort of emerging. So talk to us about why you believe that's the largest AI deployment in the real world.
Yeah, and I'm sorry, I should have caveated that by saying largest AI deployment in a safety critical application.
Yeah.
And I think that there are a couple things that make this problem unique. One is that there has not been a single architecture or a single model type that's been deployed. So it's a little bit different than the LLM space that we're in today, where everybody's using transformers and LLMs, but there are a lot of other deployments for autonomy that are using all kinds of different machine learning models and classifier models that are making sense of three-dimensional data and two-dimensional data. And so it has not been a single solution. The other is that these feed into complex architectures of sensor fusion, and so it's models on models, and it's not one single deep neural network to drive the vehicle. It actually turns out to be a pretty complicated network of different algorithms that work together to drive the vehicle.
And just to add to that, would it be fair, and I'm just kind of teasing this out, which is the scale of data that's actually generated. I mean, I know like full self-driving cars are not universally present in every part of our country today. There are pockets like San Francisco where we see them. But the scale of data that's being generated, including by companies like Tesla, is massive. And then the safety risks and the surface area of safety issues is also massive, right? And I think this, in some ways, is it fair to say the autonomous vehicle industry is almost like a decade or two ahead of where generative AI is today in terms of having to live with those safety risks and find solutions to them?
That's a good question. It's a bit of apples and oranges because I think that there are plenty of fairly mature generative AI solutions that exist today that aren't being used in safety critical applications that are working just fine, right? And I use CodeGen every day, and it's wonderful, and I'm glad that it exists. There are certainly applications where that's going to present safety issues. For what I use on a day-to-day basis, it doesn't. I think that, as you say, the surface area for self-driving is very, very large, and self-driving is unique in a few ways. One is that the number of developers historically has been very large, and the number of dollars put against development has been very large, which is corresponded to a ton of miles driven and even more miles simulated. And so there's been a lot of stress testing of algorithms in a way that I think is pretty unique to that industry. And I also think that because these things are making decisions on a cadence of tens of decisions a second, meaning that we're doing sort of real-time inference, if you like, it means that there's not an opportunity for human supervision in the way that there is for so many other applications. And so you can imagine having a ML model that you're using for radiology, for instance, where there's still plenty of opportunity to review abnormal behavior and missteps by an algorithm. And that opportunity doesn't really exist for autonomous vehicles. And I think that there's actually an interesting parallel here in generative AI, where I think increasingly our interactions with generative AI are going to be sort of real time with no human supervision. So thinking about interacting with an agent, or an agent going off and spinning up a bunch of actions, or agents crawling the web and placing orders on your behalf, yada, yada. Like those are all applications that are coming quickly, and none of those are going to have human supervision. In many of the applications that we see today, whether it's code generation or ad copy, actually do involve people actually reviewing the result and reviewing the output of the model before it makes its way out into the world. But when we get to a world where websites are rewriting themselves automatically based on clicks, like that,
Yeah.
That requires, I think, a different standard for safety.
And one last question about the AV world before we apply that same discussion to AI in the language model world, generative world. Is the AV world very mature when it comes to safety? And has it had to become a very mature industry when it comes to safety? And how do you even define safety, I guess? Is it just the risk of accidents? And is there a pretty clear kind of definition of what safety is? Because I think one of the issues we'll talk about with language models is how do we define safety, in what context, in what applications? And we'll spend some time on that, but let's, just kind of understanding how the AV world has matured around safety over the last decade or two.
It's a really good question. And I think the experience from AV is one of the reasons why I think it's so important to get going on this for generative AI. AV has been in development, certainly in with plenty of money behind it since about 2012, and preceding that with the DARPA Grand Challenge probably 10 or 20 years before that. And a lot of these core AV safety issues are still undecided. We still don't have a set of federal regulations to determine what qualifies as safe for an autonomous vehicle. It's also the case that the way that we prove safety is turning out to be just as difficult as the way that we create safety on the vehicle to begin with. And so this is a completely unsolved challenge. We've made loads of progress in the last 10 years. I think what's interesting is that we've learned a lot from traditional system safety and traditional systems engineering using the same techniques that they apply to researching accidents in nuclear power plants or aviation. A lot of those lessons have turned out to be really important in autonomous vehicles, but we're still not there. And there's still a lot of work to be done.
Yeah, so that's a really interesting insight. And so, an industry that has been around much longer and arguably significantly well funded for at least the last decade, as you said, still learning. And so it sounds like there's some insights there on how we apply that to generative AI and language models. So,
And by the way, that's also an instance where the rules of the road are very, very clear. And that's also different in the generative AI case. There are a lot of qualitative decisions that have to be made about what should be allowed and what should not be allowed.
yeah,
And in driving, it's a much cleaner story.
yeah. I mean, it's also the skill sets you're replacing to some degree. Like every driver on the road has to take a driver's test.
Yes.
Right. And so it's a very well defined replacement. And, yes, there's nuance, and yes, there's, sensor fusion, and yes, there's, human ability to respond in milliseconds, and there are other kind of complexities underpinning it. But the test is, can you drive as well, if not better, significantly better than human driver? And everybody's kind of taking the same driver's test at some point. And I think when it comes to generative AI, and I'll just talk about language models for a second, because I think when it comes to images and video, there's a whole bunch of other topics that relate to it. But starting off with language models, I think the first question I ask when it comes to safety is, how do we even define safety here? And what is the realm of safety? Because I've heard the word used in many different ways. At the core, a transformer as a mathematical model is essentially capturing sequences, probabilities of words coexisting, and based on a corpus of data, right? And so there's applications like, say, writing marketing copy, where the definition of safety perhaps is, make sure you don't sort of talk about certain things that are inappropriate, or talk about concepts that are inappropriate in copy, and that's one layer of safety. And then there's actually, what I think you're getting at is safety critical applications, healthcare being a big one, but I'm sure there's other examples that you have in mind as well, where what it means to be safe is a much, much higher bar than simply not using, incorrect words and so on. And then there's a third definition of safety that I don't think you and I are probably going to touch, which is this idea of, AGI and machines taking over the world, and, and sort of the almost a realm of science fiction and the long-term risks of models. But was that a fair characterization? I mean, do you see the world in a different lens, or is that a good way to sort of summarize?
I think that's a good place to start. And uh, I I think that it may also be a bit misleading to call this AI safety as an umbrella term,
Yeah.
because I think in many ways you could think of it as AI risk management. So you can imagine that a language model publishes information that's damaging to a brand's reputation, or violates a security protocol, or uses personally identifiable information in a way that should be disallowed. And so it it's really important in safety critical applications. There are a bunch of other seemingly innocuous applications where there are still real risks for consumers, for users, for publishers of content. You can imagine an ad copy routine doing a product summary and making misleading statements about a product that is shipped out into the world. Well, that's a huge liability for a company. And so I think as we think about the risk landscape around this stuff, it's much more than trust and safety, certainly. It's also potentially more than sort of risk to bodily harm, which is, I think, what we typically think about as being safety.
Yeah. And so maybe we tease out this in two parts. Let's pick the sort of life and death applications for a second. Let's put healthcare aside, and we'll come back to that in a couple of minutes. But let's start with just the simpler use cases for the sake of discussion. So marketing copy type, ideas, the reputational risk of brands. You've thought a lot about this problem. You've written about this problem. Are there themes or ideas that are emerging that you think are worth thinking about? Or do you think even for that sort of use case, almost a simpler use case, it's still really unclear and fuzzy how we should be designing systems for risk management or risk mitigation? I mean, any thoughts on that?
Yeah, I think that there are a couple of themes that are really important today. And ask me again in a week, and I'll probably have a different answer because the
Yeah.
space is moving so quickly.
Yeah.
But certainly one theme is that for everybody that's working on the space, they need to think about software release and risk management around process. So let's say that you're going to embed a language model into a product or a feature. What evals do you have against that? What are your requirements against it? How are you testing it? How are you assuring that that's true over time? What happens if you switch to a different foundation model? What happens if you incorporate different human feedback through reinforcement learning? And so, just like we have in all kinds of business practices, we need to come up with a risk management framework that allows us to responsibly deploy these things out into the world using a process that's agreed upon. And I think that the way that we'll get to that eventually is through a set of standards, probably a set of ISO standards. It's going to take a while to get there because we don't move that fast on standards, but I think we need to start working in that direction. The other thing that I think is a really important theme in all of this is that the performance of small open source models is absolutely astonishing. And on a number of benchmarks, these things are starting to look like equal performance to GPT-4.
Do you have any particular examples that you're thinking of as you see that?
There are a host of these. A lot of this came out of the Llama leak. And so there are now models that are much smaller, but are open source that people are very quickly spinning and training on their own. And so instead of a major investment to go train one of these models, the models are just starting to perform better and better with smaller model size and clever versions of different training mechanisms. And so we all knew that open source models were going to be a really big thing, if for no other reason than the fundamental research around transformers is all in the public domain.
Right.
There's no secret sauce here. And what's been surprising, as has been the case with so much in generative AI, is just how quickly that's come. And so I think that we can imagine that organizations are going to very quickly favor training and hosting their own small models that are able to actually do pretty well in a limited context. And so I think what that may mean for the future is that instead of having one model, call it GPT-N, that is capable of doing ad copy or code gen or healthcare applications or fill in your use case, that instead you have these more narrow context models that are much cheaper to run, they're much cheaper to train, but now you have to actually impose your own set of rules and requirements around them to make sure that a specific set of rules are being followed. And then, of course, having testing and eval against those rules to make sure that they're enforced.
Yeah, so two concepts there, just to sort of reiterate. The first one is around almost sort of software engineering best practices for testing in QA. And then the second one is actually the acceleration of open source models gives us a lot of sort of transparency and visibility into how we might build better protections within these models themselves. And on the first one, I mean, just to kind of take the idea you have and sort of walk through an example. So Quora, and cut me some slack here, but I think they call it PO, which is their sort of tool for language models. And I think it has, last time I checked, it has 7 or 8 different versions of different language models that you could plug in and play. And what you're describing is essentially a layer of testing, QA, black box sort of testing that sits on top of whatever models you're running under the hood for a tool like that, but is consistently evaluating performance. And there may be, an index that says these models tend to be like inaccurate about certain concepts, and these models tend to have content that could be racist, for example, and shouldn't be appropriate, shouldn't be displayed on the web, and isn't appropriate for the internet. And so I think there may be things like that you just that could be standardized plugins, and then anybody who's building a software product, anybody who's using these in the real world could use these capabilities almost as an API or sort of an embeddable sort of toolkits. And that would, and it sounds like something like that would actually accelerate the adoption of these models significantly.
I think that's right. An interesting example of this that came up about a month ago was a lot of folks started noticing that GPT-4 is capable of sort of quasi-compression, where you say, okay, GPT, I want you to take this long paragraph of information and then generate a string that you'll understand that will compress that with sort of optimal compression. It's not really compression because it doesn't work all the time. It's a nonlinear function, but it works some of the time. Now, you can imagine that people actually use that as a security loophole in all kinds of ways, right? And so people could just go through these different applications that are making use of an embedded model
Yeah.
and then just putting in these seemingly random strings that are then generating all kinds of output that should be disallowed. Well, that's actually a really easy thing to build a detector for. And that's probably a common failure mode from a safety perspective across a whole bunch of different model hosts, right? And because it's sort of inherent to this particular generation of LLMs. And so that's an example of something where it's like, oh yeah, we should just make sure that we have that protection in place because
Yeah.
that's going to present some risk to us that is really hard to quantify.
And it's probably going to be like tens, if not hundreds of such edge cases,
Exactly.
sort of attacks, right?
Yeah.
And risk factors that at some point, if you're a developer building products and services, you just don't have the time to keep supporting all of them, right? And so using a tool or building these in the models themselves, and we can talk about how much of that I think is happening within both OpenAI and Anthropic, because both of them have sort of at least publicly started to talk about risk management of these models for these sort of non-safety, life and death kind of use cases. So some of that might happen at the model level, and some of that might actually be a problem that needs to be solved outside the models themselves.
Yeah, I think that's exactly right.
Yeah, that's a very interesting perspective. So, like, now let's switch over and let's talk about areas where the risk increases dramatically. And I'll give you one example. And healthcare is obviously a space where there's a whole bunch of really interesting things that these models can do. In particular, in the month of April, there was an interesting paper that came out of some of the folks in Microsoft Research and OpenAI and Eric Horowitz that assessed the performance of GPT-4 on USMLE, which is the medical licensing exam in the US. And the model had a pretty strong score. And I can add a link to the paper later, and folks can read it. But it's an interesting paper that talks about this. And I think that opens up two questions. One is what role do these technologies have in critical applications like healthcare, but also the limiting factor for healthcare in particular is the cost of being wrong is very, very high. And a model that doesn't understand causality, and one could argue that for all practical purposes, the models don't quite understand sort of causality behind these medical concepts, and they're simply learning how these fit in together. The risk of being wrong in a healthcare application can be very high. So I think that's an example of situations where the risks are very high, the need for safety is even higher. And I think as a society, if we can solve those problems, I mean, it opens up so many more use cases in these examples. But I'm sure you have ideas on how we might want to approach it, or maybe even ideas on why we shouldn't even try to approach it. But before we go there, I mean, are there other domains that you think are in a similar vein, like healthcare, or any thoughts on healthcare in particular?
I'd love to dwell on healthcare for a second because I think it's a great illustration of some of the broader challenges that I think we're going to face in the coming years. One lesson that we learn over and over again in the world of autonomy is that the failure modes of autonomy are spectacular and hard to predict. Ezra Klein talks about the principle of weird a lot, which I like. I think it's a great framing for this conversation that the way in which an AI agent medical doctor is going to misbehave or make mistakes is we should not expect that to be the same mistakes that a human doctor will make.
Yeah.
Right.
Yeah.
And similarly, the ways in which we verify that a doctor is competent are going to be completely different than the ways that we verify that an AI agent is responsible in the healthcare context. So the fact that AI can do very well on a medical exam should give us very little confidence that it can be used in a variety of healthcare applications, right? Because the ways in which that score correlates really well, or at least reasonably well, with human performance as medical professionals. But we should not expect the same to be true of AI agents. And AI agents, we have to remember at this point in time, they're really just doing next token prediction. And there are some amazing emergent qualities that come out of that, but none of that is underpinned by any kind of rational, logical reasoning.
Yeah.
And that's, I think, a really important thing for us to all keep in mind as we think about these deployments.
So what happens there, Randall? What's a path forward, I guess?
Well, I think that we need to become really comfortable with the things that these models are good at and be comfortable with the things that they're bad at. And I think that in many ways that can literally boil down to the tokens that have high probability and the tokens that have low probability. And so I think it's reasonable in a lot of applications that if a model outputs a numerical output, we should highlight literally the numbers and say, go double check these numbers because it's unlikely that these are going to be right the vast majority of the time. In other cases, we can ask for general guidance on all kinds of things that may otherwise occupy the time of medical professionals that could easily be served up by a model in a way that's probably better than Google search in a lot of ways. So I think that I really like the Bayesian framework of saying, as long as you apply the right error bars to data that you have coming in, all data is useful. And so as long as we are able to make use of the good parts of the model and discount the bad parts of the model, that should allow us to get stuff out in the world.
Yeah. I think having seen machine learning based sort of predictions in healthcare for a long time. And I know language models are a different beast and they unlock a lot of new things we couldn't do before, but many of the risks are actually similar, right? So if we were predicting the risk of a person having a certain ailment based on clinical data using any other classifier, any other Bayesian model that you like, right? I think what you do if the model is right and what you do if the model is wrong are scenarios that you have to consider. And one of the mitigation tools that we've used over the last several decades is actually what is the intervention and the cost of the action that you take based on that outcome, right? So predicting, let's say a person is likely to have a certain condition, sending an ambulance to their door is a very high cost intervention, but surfacing that up as a clinical decision support tool to a provider and saying, here's, something you should look at is a much lower risk, sort of much lower cost, much lower sort of risk intervention, right? It's sort of adding human insight or human oversight in the loop is really where I think a lot of the applications are. And so I think some of the stuff you said around the black box testing ideas do apply to these healthcare use cases. As an example, just going deeper into healthcare, I'm sure there are other high-risk industries as well that are equivalent challenges. But also, I think we can think about the cost of interventions, what we do with those interventions, what actions are we really driving, and is there a human in the loop? And it feels like, as much as I'm really excited about the promise of these models in healthcare and just generative models in general in healthcare, I think we still have a couple of fundamental challenges in healthcare applications of these models. I think the first one being humans are just better at interpreting real world data than machines are, even with the advances in machine vision, like what a doctor is reading in their visit, what a nurse is reading in their visit is actually a really hard problem. We're very, very good at interpreting multimodal signals and drawing insights intuitively as humans. And I think machines have some way to go there. I mean, they can do single tasks well, so maybe they can just read x-rays really well, right? But that's different from what's happening in a primary care visit. And then the second part being the way you think of risk of being wrong and what you can do with the actions, I think is also going to be a problem that takes some time to solve. I think there's some promising techniques. I think some of the ideas you shared are really interesting, but I think we're probably at least half a decade away, if I had to bet, on real clinical use cases of these models without humans in the loop, without human oversight. I mean, I would be very excited to be proven wrong, and you can push on the timeline and tell me it's a completely wrong timeline, but just putting a stake in the ground.
Yeah, gosh, it's really interesting that there are a number of interesting parallels to the autonomy domain where we literally assign scores to different kinds of actions that an autonomous vehicle can take. And so slamming on the brakes or departing the lane or running a light, but those are all things that we can actually associate with very specific hazards and risks. And so I think you're exactly right. I think that's a fantastic framing to think about this. And I think that if maybe the other lesson that we can take away from autonomy is that as an industry, we completely overestimated the speed with which we could get this stuff commercialized and out into the world. And actually, if you look at the risk landscape of autonomous vehicles over the last 10 years, the fatalities, and there have been fatalities, the accidents, and there have been many, have all come during development while people are trying to figure this out. And I think that there's going to be real risk associated with trying and experimenting with generative AI over the coming years with overestimating its capabilities to some extent.
And going back to the start of this discussion, right? I think this gets even harder, and I'll just use healthcare as an example and double down there. It gets harder for healthcare because, as you said early on, driving is a very universal benchmark, right? Versus the healthcare applications and the predictive power of healthcare applications. There's a very long tail of predictions that you just don't have enough training data. You just don't have enough samples. And so, if you're trying to predict certain things in like a rare form of cancer, it's not an easy population to simulate like you can with a self-driving car. I mean, like the simulators in self-driving cars have gone really, really good, at least as an outsider. It feels like, a lot of that's happening in the simulator world now. But doing that with synthetic data and simulating those scenarios is still significantly hard, which means that you really have to maximize what you learn from a very small sample of people in these, especially in this long tail of conditions, right, outside the diabetes and kind of heart disease in the big five or big six. And so I think it's going to be a slow shift. And I think the promise is there. I think the promise on the other side is better care and more cost-effective care and so on. But I think it's a really tough technical problem.
Yeah, and it may be the case, you know much more about this than I do, but it may be the case that many of the applications where healthcare is going to be really benefiting from the presence of generative AI is going to be doing the dumb, boring paperwork stuff.
Yeah.
And helping process insurance claims and helping schedule appointments. And that is a huge burden. My dad is a small town doc, and a huge part of his day is spent dealing with dumb paperwork. And I think the degree to which we can use these tools to free up healthcare providers to actually provide care is a huge gain and potentially higher impact in the near term than actually doing the clinical work with at least this generation of algorithms.
Yeah, I think that's exactly right. Yeah, and we can probably talk about this for hours, but then the other place we go with, which is the open source, smaller models, and the question to ask in healthcare data. And there's some really interesting stuff happening there as well. There's really good models, including with Google has a couple they've shared publicly, MedPalm and others. But the limitation there is the size of the training data. And how much can you actually learn on, and do you have enough there to sort of do really interesting stuff with the model that's created? So again, I think it's really exciting for the field, but it's still very much an unsolved problem. I think we're like 30% of the way there, if I had to guess. And I think this is another 3, 5, 7-year journey at least.
Yeah, I think that's right.
Maybe I'm wrong, right? Things are changing so fast.
Yeah, no, I think that's exactly right.
Yeah. All right, Randall, this has been a ton of fun. I think one of my favorite things about doing this podcast is I have all these incredible people I meet every day, and just kind of getting to spend time with them and like sharing this with the world has been really rewarding. So, any parting thoughts or comments or feedback before we wrap?
Thanks so much for the time. I really appreciate it. It was a fantastic conversation. And I think with your experience in actually seeing models deployed in healthcare, it's going to be really important to have this next generation of models grounded in all of the realities of fielding this stuff. So I'm really excited to see where this goes.
Yeah. And thank you for coming in from AV, which is an adjacent field, but I think healthcare can learn a lot from the experiences you have, as well as other domains.
Hey.
Yeah. Cool. Well, thanks again, everyone, for listening in. This is the Autonomous Health Podcast, and thanks again, Randall, and great conversation. We will try to release our episodes on a regular cadence, and you should be able to find them online as well as in your favorite podcast app. So once again, thanks again. This is Anmol, and have a good rest of your day.